Okay, good morning, everyone. So, welcome to week 9 of the Apprentice course. This will be sort of our final week. Next week is more of a review session, talking about the master beekeeping testing and really trying to schedule future events. This will be a really fun talk today, talking about the history of beekeeping. And, Texas has a really rich history of beekeeping. And so, as I was, I'm pretty new to Texas. I've been here for almost a year now. And I've been learning a lot about the history of beekeeping in Texas. And so I'm still learning a lot more, and hopefully you guys take a lot out of this. And, you know, at one point, Texas was really the center of beekeeping in the entire country. And so I'll talk about, that and the history of beekeeping. So when I talk about beekeeping, there's really, I guess there's about four major eras of beekeeping, and I'll talk about each of these separate eras. So we have the era before the 1600s, including the decades and years before BC. We have the years of 1600 to 1851. This included the introduction of bees to the New World. 1852 to 1987 is where beekeeping as we see today really exploded. And this really coincided with the invention of our Langstroth colonies with removable frames and all these modern hive technology we have today. And then we have from 1987 to what we have now. But before we begin, we talk about sort of the bees across the entire world. And so, in order to understand honeybees, we need to understand the other bees that people manage or don't manage across the world. So, I like to include here just a few definitions. And so, honeybees are a species, right? So, there's different species of honeybees. So, we call them Apis mellifera, but there's different Apis species. So as we talk more, we'll have Apis mellifera, which are the European honeybees that we manage. We have Apis cerana, which is an Asian honeybee. We have Apis dorsata, which is the giant honeybee. So these are all different species under the genus Apis. But I'll talk about other different species, including, bumblebees are a separate species from honeybees and so on. And then with Apis mellifera, which are the honeybees we manage today, there are about 20 to 25 different subspecies of Apis mellifera. These just basically mean that, these honeybees are in different regions of the world, and based on where they're found and based on the climate they're around, they've evolved to be these different subspecies. So, for example, we talk about Italian honeybees, we talk about Carniolan honeybees, we talk about Africanized honeybees. These are all subspecies underneath the Apis mellifera umbrella. And then we have lineages. Lineages basically means these broad groupings that are more similar to each other. And so in Africa, we call that a lineage, and all Africanized subspecies are under this a lineage. And there's quite a few, I guess, Africanized subspecies, about 15 or so, and these are all under this a lineage. And then we have, M lineage, which would include, Italian honeybees, Carnival, and so on. And then we have breeds. Breeds are basically honeybees that are bred and selected for specific traits. So we have numerous breeding programs across the United States. So we have the pole line breeding program at Baton Rouge, the Purdue mite biters, we have Saskatraz. These are specific breeds. So first, I always like to talk about the corbiculate bees. So corbiculate basically means it stands for the pollen basket. So when we talk about honeybees, one thing that makes them unique is they have this large hind legs called a corbiculate or the pollen basket. And this allows these bees to go out to flowers and collect large amounts of pollen, not only to bring back to their colony, but also to pollinate other crops. Now, there's a lot of these different corbiculate bees. So one of the most fascinating is Tetragonia carbonaria. This is the sugar bag bee. They're stingless bees, and they're managed not only in Mexico, but they're managed in Australia and parts of Asia. Now these are stingless bees, but they form a kind of similar nest to honeybees, and they do produce a honey. The honey tastes a little different, but they're really fascinating bees. But Tetragonula, which was probably one of the earliest bees that was managed, so the Mayans managed the Tetragonula type bees for honey production. Then we have Bombus, so the bumblebees. So bumblebees are also a corbiculate bee. We have Apis mellifera, which are the honeybees that we manage, and then we have Euglossa, which is the orchid bee, and they collect pollens from certain scents to attract the females. So these are all under the corbiculate bee. Now, what's interesting about these different corbiculate bees is Apis mellifera, they're they're known as a social organism. What that means is they form these perennial colonies that have somewhere between 10 to 20,000 bees. They have reproductive castes, so they have a queen and then non-reproductive workers, and they basically form these colonies year round. The females, the queens, also mate with multiple males. So the queen will mate with somewhere between 15 and 20 males. Now, for the other corbiculate bees, bumblebees form kind of smaller colonies, but they switch from a social colony to solitary phase in the winter. So basically, the maid queen burrows into the ground over the winter and then merges and forms a nest. And so when that happens, the entire nest dies, and that queen will live and form a new nest in the following season. And so, unlike honeybees, these bumblebees are switching from a social colony into a solitary phase. Tetragonula, these are Melipona. These are other social bees, and the Euglassa is a solitary bee. So they all have different differences, but they're all very similar in that they have the corbiculates or the pollen baskets. Now, one of my favorite bees are the stingless bees. And so they form these kind of circular nests, and they have a lot of resin in them. And so you look at these nests very closely, they have a lot of this resin or propolis. And so, some of you haven't gotten your bees yet or are about to get your bees pretty shortly, or maybe you just got your bees. And one thing you'll realize is bees collect resin, produce propolis that are basically a glue-like substance that sticks boxes together. Now, for beekeepers, it's kind of a pain. They use a hive tool to basically break that propolis seal and separate the boxes. But the Tetragonula or the stingless bees, they produce a lot of this propolis. They're also excellent pollinators. So they're really great pollinators for a lot of these tropical crops like mangoes, coconuts. They also help pollination for avocados. So they're important pollinators in Australia, Southeast Asia, and also in Mexico and Central America. They do produce a unique type of honey, and so it's known as sugar bake honey. And these bees are called sugar bake bees because this honey is kind of a tangy flavor to it, and it's highly valuable for its medicinal properties. And like I said, they produce these resinous cavities. And like I mentioned in week one, the resin is a really important antimicrobial substance that bees produce to protect its colony from pests, pathogens, diseases. Now, these bees produce a large amount of resin. And these bees only thrive in warm climates, and so you will never find them in these more temperate climates. So you'll find these bees typically in like South, Central America. You'll find these in Southeast Asia, Australia, kind of those more tropical environments. And I'll show you a video of them. The other bee is an orchid bee. So this is another type of corbiculate bee.
It's me, an orchid, and I'm one of the most cunning of all flowers. My perfume is a trick. Orchid bee depends on me for help with his central mission in life, to mate with a female. For weeks, he collects scent oils from orchids. Eventually, he uses his mix of fragrances as a kind of orchid cologne to attract a female. The scents come from me, a bucket orchid. The bucket is part of my trick. The bee has to climb a waxy slope to reach the scent oils cleverly hidden beneath a hood. I filled my bucket with a sticky fluid that makes the bee sink. I provide only one escape route, which leads him just where I want him. After the bee climbs out, I grip him tightly. I glue two pollen sacs to his back, each filled with tens of thousands of pollen grains. These are the only pollen sacs I will ever produce, so I won't let him go until the glue is dry. I may wait an hour or more before loosening my grip. This one bee now carries my legacy. When he comes upon the scent of another orchid that same day, he heads right for it. If he slips into the bucket of this second orchid, the pollen sacs on his back will come unglued. Pollination can occur. A new orchid generation can begin. How nature has created such intricate strategies is a mystery of life. Yet we can unravel some of the puzzle if we go back in time, back nearly 200 million years, during the age of reptiles. There were no mammals larger than a mouse. For a very long time, there were no flowers either. Without flowers, Earth was a drab place.
Yeah, and orchid bees are probably my second favorite bee. They're a really fascinating bee, and actually there's some orchid bees found in South Florida, but they're typically in the Southeast Asia area. And what's really cool about them is they're brilliantly colored. So they have these kind of bright metallic colors. Like this was a blue orchard bee. It has this kind of green metallic with blue metallic legs on it, but they can come in purple and these really bright gold colors. And what these males do, and as they show in the video, is they go to a bunch of these orchids and collect all these different floral senses. And based on the type of floral senses that they're collecting, that's what they use to attract females. So females are basically trying to find what male smells the best and what perfume smells the best for those females. And that's how they're kind of finding the males. So it's a really cool bee. And if you have a chance to go to the southern part of Florida and find them, they're really cool and beautiful. You can find some really great videos online about these orchid bees flying around, but they're really beautiful bees. They're really strong flyers, so they have powerful muscles and they can fly extremely long distances to search for all these fragrances and perfumes. So they're really strong flyers and they go to a lot of different sources to find as many smells as possible. And like I said, they can be found in South Florida and they're really important pollinators for orchids. So they form this really great mutualistic relationship with the flowers, where the flowers need these bees to spread their pollen to other orchids. But the orchid bees also need the orchids to collect the senses and fragrances to attract the females. And then we have bumblebees. So when I was talking about, the Tetragonula, they're in these social colonies. Euglassa, they're solitary bees, so they don't live in these social colonies. But bumblebees live in these sort of semi-social colonies. And so you can actually buy a bumblebee nest. So if you ever want to try beekeeping with bumblebees, you can definitely do that. And they form all these nests, and you can see all the workers are about the same size as a queen, but only one of these bumblebees will be a queen. It's based on which one's most aggressive. So the most aggressive bee will basically become the queen. But if that queen dies, any of these workers can become a future queen. But what happens is they form these kind of perennial colonies. So they form these social colonies. And at the end of the season, the whole colony dies except for one queen. She mates, she burrows into the ground over winters, and the next year she emerges, she builds a nest, she collects all the resources, and she makes new worker bumblebees. And then these bumblebees form a future colony. So unlike honeybees, where they're a colony for an entire season, the bumblebee switch from a colony into a solitary phase. So it's very diverse. There's about nine species of bumblebees across Texas, and a lot of these are going endangered, like the rusty patch bumblebees. They're very sensitive to the environment and pesticides and things like that, and so they are a species of bees that are really endangered and have a lot of issues. But they're really important pollinators for many crops, such as tomatoes, peppers, and blueberries. A lot of people maintain these bumblebees in greenhouses to pollinate kind of greenhouse fruits and vegetables. They're annual, which means that the colony dies off in the winter and only the new queens actually overwinter. And like I mentioned, with declining populations, this can be due to habitat loss, pesticides, and changes in the weather. Now we talk about apis. So Apis mellifera are a specific species of bees. We like to call them the honeybees because they produce large amounts of honey. But there's different species of Apis. So Apis is a genus, and mellifera is a species name. So these are all the different species of honeybees. So we had this sort of split into three major categories. We have the cavity nesting honeybees. So this includes Apis mellifera. I'll talk about Apis cerana, but these are managed by beekeepers across the world, primarily for honey production and their wax. We have the giant honeybees. These honeybees are quite a bit larger than Apis mellifera or the honeybees that we manage. They don't form in cavity nests. They form nests on tree branches, and they form these kind of large wax. But they actually don't form like a cavity like the honeybees do. And last week we talked about AAA laps and the giant honeybees, so we have a little bit of background on them, but they have these really great defenses. So they have this shimmering pattern where they do a full shimmer to scare off any predators or trying to get to the nest. We have the dwarf honeybees, which are the small honeybees. So this just means that all these are different species of Apis. So this is Apis cerana. These are managed in Asia. They don't produce as much honey as honeybees, but they can produce a smaller honey. So you can see that in Asia, they're managed exactly the same. The bees look actually very similar to the bees that we manage here in the United States. They're a little smaller. They tend to be a bit more aggressive, but they can produce a little bit of honey. So these are primarily managed in Asia. And so as you can see, they still have their same removable frame, the same lengths with colonies. They're still really taking advantage of the bee space, and so they're really really cool bees. So they're native to South and Southeast Asia. But these were actually the original hosts for Varroa destructor. So what happened was these Varroa were living on Apis cerana for hundreds of years, and they jumped host to Apis mellifera. And that's one reason that it spread across the world and became a huge problem that we deal with across the states, especially here in Texas. But Apis cerana, because they dealt with Varroa for very long, they had these natural defenses and resistance to Varroa. So they have intensive grooming behavior and intensive hygienic behaviors that allow them to combat and have resistance to Varroa. As you can see, their Apis cerana is smaller than Apis mellifera, not by much, but still a little bit smaller. They tend to be a bit more defensive and more aggressive. They also produce less honey than Apis mellifera. They similar to Apis mellifera, which are honeybees, they prefer tree hollows and man-made structures like length-growth colonies, but the colonies are typically smaller. This is a picture of the Apis dorsata, which is a giant honeybee. Talk about here. So this is a picture of the giant honeybee, and so like I said, they don't form nests in cavities or trees or man-made structures. They form them on tree branches. And one of their defenses is shimmering pattern. You see how they're shimmering. So like there's a hornet right here or a wasp coming towards their nest, and they do the shimmering pattern to really deter the pests away. So this wasp is coming, they're using shimmering, and that pushes the pests away. They also do this for any rodents or anything that's coming to disturb or take away any of their products. So this is the largest honeybee. So it's quite a bit larger than both Apis mellifera and Apis cerana. They have open nests, so they're living on these trees, cliffs, buildings, rather than inside a cavity. They're highly defensive, and they have this shimmering pattern to deter any predators. What's interesting about the queens for Apis dorsata is, they mate with somewhere between 60 to 100 males. So, honeybees that we manage here in Texas, those queens will mate with somewhere between 12 and 15. These queens for Apis dorsata are mating with, upwards to 100 males during their flight. So they have these, massive congregation areas for mating. They're also seasonal migrators, so they can travel extremely long distances. And so they have this absconding behavior where if something happens to the colony or predators go into the colony, they can migrate miles and miles away to form a new home. And because they're not living in a cavity, it's easier for them to move and migrate. They also migrate based on floral resources. And so if there's a drought or a dearth, these bees will migrate to a new home based on the conditions. So they're really strong flyers and they have this intensive migratory pattern. Okay, now we get into Apis mellifera. And so like I mentioned beforehand, Apis mellifera are a species of honeybees, but they're different subspecies of honeybees. So we talk about Italian honeybees, we talk about Carniolan honeybees, we talk about Africanized honeybees. These are all subspecies of honeybees. And there's over 20 of these different subspecies, and they have different traits based on where they came from. And so, as I'll get into it, honeybees are non-native to the United States, and they were imported around the 1600s. And so, these bees have become adapted and acclimated to the specific areas. So this orange right here, this is Apis mellifera mellifera. This is a dark German honeybees. These were the bees that were first imported into the United States around the 1600s, 1622 time. The yellow is Italian honeybees. So these are the ones that we primarily manage in the United States. They're really great honey producers, but they're more prone to pest pathogens and diseases. And so there's a lot of valuable traits to them, but there's some downsides. The black or the red right here, this is the Carniolan honeybees. They're more cold tolerant. They're more they don't produce as much honey, but they don't build up as fast in the spring and they tend to shut down. And so they have different traits there. And bottom we have Africanized honeybees. So these are colors really denote the different subspecies of honeybees across Europe, Asia, and Africa. Now, what we like to do is we like to group them into different lineages. So, we have 20 or so subspecies, but they can group into these different lineages. And so I'll talk about these lineages a bit more, but we have A lineage. So this means the Africanized honeybees. So there's different subspecies within Africanized, and they're very similar to each other. M lineage is basically the dark German honeybee. So this is in the purple colored. And C lineage is primarily the genetics we have in the United States. So C lineage would include Italian honeybees, Carniolan honeybees, and so on. And these are the large honey producers. And so, this is one way that we can group these different subspecies into common groupings. So these are the different subspecies of Africanized honeybees. So I think we just assume that all Africanized honeybees are the same, but if you look at just the entire continent of Africa, it is huge. And there's differences in mountain ranges, differences in climate, differences in floral resources. And because of that, there's different subspecies based on where they're found. And so I think there's one, two, three, four, five, six, seven, eight, nine, 10. There's 11 different subspecies of Africanized honeybees. Now we have Apis mellifera unicolor, which is found in Madagascar, Apis mellifera compensis, which is found in South Africa. This is a really interesting bee, which I'll talk about in the next slide. But what they can do is the workers can actually produce fertilized eggs. And so what they do is they go into Africanized honeybee nests and take over the entire nest and kick them out. Apis mellifera lamarckii, which are the Egyptian honeybees. These were imported into south part of Texas, and so you can still find some of the genetics in the Sam Houston forest. They tend to be almost even more aggressive than the Africanized honeybees that we know today. Apis mellifera geminica, which I found in Saudi Arabia, these are extremely heat tolerant bees. They tend to be quite a bit smaller than the bees that we manage today, but they have these valuable traits that allow them to really persist and thrive in these kind of hot desert arid environments. Apis mellifera latoria, which is also found in Saudi Arabia, intermisia, which is found in Libya and Morocco, uh, Apis mellifera adansanii, which is found in Madagascar also, Sahariensis, North Africa, Mandicola, the East African mountains, and so on. Now, this Apis mellifera scutellata, this is the one that we hear a lot about in the news. They're sort of known as the killer honeybee. These were the bees that were imported into Brazil around the 1950s and made its way into Texas around 1991. And so when you think about Africanized honeybees, we talk about the Apis mellifera scutellata, which make up the most of the Africanized genetics in Texas. And so even though there's a lot of subspecies of Africanized honeybees, basically scutellata and Lamarckii were the two that were imported into the United States. But one I want to talk about is the Cape honeybees. These aren't found in the United States, but they're found in South Africa. And these Cape worker bees can lay diploid eggs. So remember what we talked about during the second session is fertilized eggs become females and unfertilized eggs become males. And so we have some situations where your colony becomes queenless for long periods of time, and the colony becomes, hopelessly queenless. And so what that means is the worker can become a laying worker and start laying a bunch of unfertilized eggs that become future males. Now, workers cannot mate, they can't lay fertilized eggs, and so, they're kind of forced to just lay a bunch of males. But for these Cape honeybees, these workers have this thing called parthenogenesis. So that means is even though they can't mate, they can produce diploid or fertilized eggs that become future females. And so what they do is they fly out to Africanized honeybee colonies, the Scutellata colonies, take over their colony, start laying a bunch of eggs, and then replace the existing queen with their queen. And so Cape honeybees have really pushed out all Africanized bees out of South Africa. Africanized honeybees, these are the ones that we all know and love here in Texas. They're known for being aggressive and very defensive. They are well adapted to tropical and arid environments, and so they do really well in Texas, for example, especially southern part of Texas. And so Africanized honeybees, they don't do very well in the northern part of the country, and so that's why they really don't pass into like really Oklahoma. They're found more in the southern part of the United States. They tend to swarm more often than European honeybees, and they will abscond and fly out and form a new home if they have varroa or any pest pathogen diseases or there's a lack of floral resources. Now, Apis mellifera scutellata was imported into Brazil around 1951 and then made its way into Texas around the early 1990s, I think 1991 or so. And since then, they spread across the entire southern part of Texas. But all bees in Texas have some Africanization. We've even found some Africanization in the northern part of the United States, like in the Dakotas, Minnesota, Montana, places like that. Now, how Africanized are they? It's very low, maybe 5% Africanization, whereas in Texas they could be 20% Africanization. But some of the genetic tests we've done, we haven't found any, I guess, pure Africanized stocks. So we haven't found any honeybees that are 100% Africanized. They're usually somewhere between, 5% to 20% Africanized. So most of our bees here in Texas are hybrid. And one thing I want to notice is, we did some studies in Puerto Rico, and the bees in Puerto Rico are basically 100% Africanized, but they're very docile and easy to work with. So we don't have to wear a bee suit to work with those bees in Puerto Rico. And so that basically means that just because a bee is aggressive or defensive doesn't mean they're Africanized. Because I've worked with bees that are all Italian and they're really aggressive. And so just because they're aggressive and defensive doesn't mean they're Africanized. The Egyptian honeybees, so this is Apis mellifera lamarckii. They're kind of similar to Africanized honeybees. They're smaller, dark colored honeybee, and they're adapted to the kind of hot, arid climate, so they do really well in the southern part of Texas. We don't find much of these genetics anymore, but they were introduced into Texas in 1862, and some of the genetics are still found in the Sam Houston forest. Now, these bees tend to be a bit more aggressive, and so if you have bees in, I guess, kind of Houston area, one reason your bees may be aggressive is because they may have some of these Egyptian honeybee genetics in them rather than Scutellata, because these bees tend to be a bit more aggressive than the Africanized honeybees like Scutellata. Now we have old lineage. So these would be the Middle Eastern and Asian honeybees. So we have Apis mellifera caucasica, which are found in Turkey and Armenia. So when we think about the Caucasian honeybees, this is where these bees originally came from, the Turkey Armenian area. Apis mellifera meta, these are found in Iraq. These bees were not imported into the United States. Apis mellifera cypria, Cyprus Islands. So when I get to when these bees were imported, these bees were imported into Texas around 1905 in Beeville. But we rarely found these genetics in the United States anymore. Apis mellifera armenica is also many honeybees. Anatola, Turkish honeybees. mellifera Adams, Crete honeybees, and the Palmanella, which are found in the Tian Shan Mountains. And these bees were the Palmanella. They were collected, sperm samples were collected from Washington State University probably about a decade ago now. And these genetics were actually just introduced into East Texas around the Beaumont area. And so Texas is the only place in the United States that has any Palmanella genetics. So Caucasian honeybees, these are the ones that some beekeepers can buy. There's a few queen breeders across the United States that still maintain the Caucasian honeybees, and they're native to the Caucasus Mountains. They have extremely long tongues. So as I get into some of the honeybees that are imported in the United States, one of their major issues was they have very short tongues. And because of these short tongues, they're unable to pollinate, collect resources from a lot of our native plants in the United States. What's great about Caucasian honeybees was these very long tongues. So that allowed them to get into some of the plants and collect some of the floral resources. These bees are also very prolific in collecting propolis, and so they produce large amounts of propolis. And these bees were introduced in the United States around 1910. The Cyprian honeybees, these are native to Cyprus in the eastern Mediterranean. Similar to some of the other bees we talked about, they're adapted to the hot, dry climate. These are also very gentle, but they also produce less honey. So one reason that a lot of beekeepers maintain Cyprian honeybees is because they're very docile and gentle and easy to work with. And so even though they produce less honey, a lot of beekeepers like to manage them because of that. And right around 1880 to 1910, there's a huge push to introduce Cyprian honeybees into the United States. And so they're introduced across 13 states, including Beeville, around 1905. Then we have Palmanella honeybees. So these are native to mountainous ranges of Caucasus and regions around the Black Sea. They're very similar to Caucasian honeybees, but one thing that was really great about them is they're excellent apple pollinators. And so one reason that people wanted to import them to the United States was for apple pollination. And with all these bees, right, they're kind of found in different areas of the world. And based on where they're found, what plants they're kind of pollinating, they become adapted to those flowers and the area. And so each of these subspecies have different traits that can be valuable to you as a beekeeper. And like I said, they're introduced in Beaumont, Texas around 2022. There's only one queen producer that currently has Palmella in the entire United States. And then we have M lineage. So there's only two subspecies of M lineage. We have Apis mellifera mellifera, which is known as a dark German honeybee. These were the bees that were first introduced into the United States around 1622 in Virginia. They have very short tongues, and so they were really great because they're very gentle and easy to work with. They're also cold tolerant, but the problem was they're very short tongues. So they didn't produce a lot of honey here in the United States with the native plants that we have. And the Apis mellifera iberensis, which is found in Spain and Portugal. So the dark German honeybees, Apis mellifera mellifera, they're well adapted to the cold climates. They also tend to be a bit more aggressive than Italian and Carnio honeybees. They're very dark black colors. So this is a picture of dark German honeybee. You can see just how dark and black they are. They're even darker than the Carnio honeybees that maybe some of you manage. And they have kind of a smaller, more compact body. Bees are a bit more aggressive. They may be replaced by gentler, more protective subspecies like Italian and Carniolans. And so if we go back to the 1600s up to around 1880, these were the primary honeybees managed across the entire United States. But because they were, a bit more defensive, they didn't produce much honey and didn't do as well in the United States, beekeepers started importing, gentler, more productive subspecies like Italians and Carniolans. And so most of the genetics that we have in the United States are primarily the Italians and Carniolans. And like I said, they were first introduced in the United States around 1662 and introduced into the Trinity River of Texas in 1821. So these are the first bees introduced into Texas. And these are the bees, the seed lineage are the bees that we primarily manage in the United States. So, if we sequence your bees, about 80% of the genetics are going to be the seed lineage. And so these include Apis mellifera ligusca, which are the Italian honeybees. So these are found in northern Italy. We have Apis mellifera carnica, which are the Carnio honeybees. These are found in Slovenia and the northern Balkans. Apis mellifera cricopia, southern Greece. So these were introduced in the United States, Macedonica, and Siciliana. So these are subspecies that are found in kind of that southern European area. But the only two that were introduced in the United States are Ligusica and Carnica. So Italian honeybees. So Italian honeybees are known for being very docile and easy to work with. They build up colonies really quickly. So unlike some of the other subspecies, these bees form extremely large colonies. So they can form, 30,000 bees per colony. So they're extremely large. They're excellent honey producers, so they produce the most honey. So they're really valuable in that way. They produce a lot of wax, which is really valuable for a lot of religions. But one issue with them is they consume a lot of honey stores in the winter. And so, especially here in Texas, when we have these kind of warm spells throughout the winter, these Italian honeybees can build up and go through the honey stores really quickly. And so they may not do as well here in the winter in Texas. They also produce less propolis and they're more prone to diseases. And so these were the second bees that were introduced into Texas around 1881. And then we have the carniolan honeybees, so they're also very docile. They actually form really small colonies, but they build up really quickly in the spring. And so what's great about them is they don't go through honey stores really quickly like Italian honeybees. They form smaller colonies and make it through the winter. So they're really great at making through these winter stores without going through all the honey stores. But in the spring, they can build up really rapidly, especially here in Texas when you have a really great spring honey flow and pollen flow. They're cold tolerant and so as people started moving farther west into Texas, into the Midwest, the dark German honeybees and Italian honeybees didn't do as well because of the winters. And so Carniolan honeybees were introduced because they're more cold hardy and were able to make it through the winter and survive through the winter. And so these became really valuable honeybees. They were introduced into the United States 1877 and first introduced into Texas in San Benito in 1910. Okay, now we'll get into the history of beekeeping. So we talk about the different eras of beekeeping. So we have all the beekeeping below before 1600s. We have the beekeeping era from 1600 to 1851. We have the beekeeping era from 1852 to 1987, then 2001 to now. So when you think about beekeeping before the 1600s, people have been keeping bees for thousands and thousands of years. And this was one of the earliest arts found on, cave walls about beekeeping in eastern Spain. So this photograph is from 6000 BC. You can see this individual is climbing the ladder, going into a honey cave and collecting honey from these nests. Now, these weren't managed by beekeepers, but these beekeepers would find these kind of honey caves or trees where these feral colonies were living, and they'd go and collect the honey and wax from these sources. And a lot of these areas across the country still collect honey and keep bees this way. And so you can find some really great videos on YouTube of people in Africa and parts of Europe going into these honey caves and honey trees to collect honey sources. But this really to show that, people have been keeping bees, dating back to around 6000 BC. And honeybees have been around for, really around 65 million years ago. And so, people probably been keeping bees even before that, but this is sort of the earliest visual art that we have now. One way that people started keeping and managing colonies were by these mud and clay hives. So, this is a picture from Israel in 1000 BC. This is a clay hive that they managed. So you can see it's a cylinder shape. It's made out of clay and mud, and bees would form colonies in here. And so when they want to collect honey or wax, they go into these clay or mud hives, cut out the wax, and extract the honey that way. Sorry about the moan in the background. And so, yeah, if you go back to 1000, this is probably one of the earliest managed colonies that people had. But if we go back to the Egyptian period, Egyptians were some of the earliest beekeepers, and Egyptians use bees, honey, and wax for a lot of different things, for ceremonial reasons, for medicinal properties, and is a very valuable source of food for the Egyptians. And so this is a picture of the tombs from Rick Mears' tomb in 1450 BC. You can say they have these cylinder clay mud beehives, and they're collecting honey and wax from these beehives. And they form these in these kind of huge areas, which I show a picture of. But they have thousands and thousands of these honeybee colonies living in these clay and mud colonies. Here's another picture from Pabasa's tomb in 610 BC. So similar, they had these kind of circular cylinder hives made out of clay. And this is a picture of people in Egypt still managing these colonies. So this is a wall apiary south of Minya in central Egypt. And see, they have thousands, hundreds of these clay cylinder beehives. And so they manage these beehives in here. They go in, they cut out the wax and the honey and collect honey that way. And so this is the way that Egyptians were managing honeybees for thousands and thousands of years. Now, why was honeybees so valuable? So one was honey was used as a sacred and sweet gold. So they use it in offerings. So for trading, they trade honey to individuals. They use offerings to the gods. So it's a very valuable source because they viewed honeybees as a like so the perfect organism, the perfect society, and they use honeybees as a model for understanding how a society should be formed. Because you had tens of thousands of bees working together for the betterment of the entire colony. And so Egyptians, saw that and found that this was a perfect society formed by God. They use it for medicines. They also use it for embalming. So they use it for mummies and embalming the mummies when they put them into the tombs. Beeswax for templates and tombs. So beeswax was essential for sealing jars. They use beeswax for making candles, and they also use beeswax for creating arts and amulets. It's a very strong symbol for royal power. So the bee symbol represented in Lower Egypt was tied to the pharaoh's title. And so when a pharaoh and a mummy was put into a tomb, they'd store honey into those tombs with some of the pharaohs because it represented um, was tied to the pharaoh's title. And so when you talk about we found honey that was thousands and thousands of years old, but it's still good, it's because this honey was found in these tombs, and they found that the honey was still good to consume. This is a picture of an Egyptian pouring honey into the vessel. I'm not sure how far this dates back, but probably tens of thousands of years ago. Egyptians, like I mentioned beforehand, they used wax in a lot of art forms, and so they developed this art form known as acoustic paintings. So what they did was they took wax and they mixed it with a colored dye, and they used that to make layers and layers of wax, and they'd scrape it to have these different colors and art forms. So this is made purely out of beeswax and resin. These two art forms. So this is the famed mummy portrait. This is the Peter Apostle encaustic arts, but this is all made out of beeswax and resin. And I'll show you sort of a quick video of how they do encaustic arts. Oh, my apologies. Let me try this again.
We're not hearing anything.
Oh, you're not hearing anything? There's it's just a background sound. They're not saying anything.
a bit like cooking, isn't it, really? Fluidity of the medium allows me so many different possibilities.
Yeah, so if you have a chance to try encaustic painting, I did a workshop with George Hansen. He's really heavily involved with the beekeeping industry across the entire country. And so he donates a lot of his own encaustic paintings to a lot of organizations, including the Texas Beekeeper Association. So if you end up going to the summer clinic in Abilene in mid-June or um, the the Texas Beekeeper Association meeting in November, he usually donates an encaustic painting. They usually go pretty high, a few $1,000s, but they're really cool painting. But it's really cool how they mix the wax with the pigments to make these different paintings, and then they use different tools to scrape the paintings and form these different visuals. So what George simply does, and I'm not an expert at this, but he'll lay a bunch of layers of pigmenting wax, and then he'll use different scoops or different tools to basically scrape that away to get the different colors and textures. So, it's really cool, and it'd be cool to have an encaustic art, I guess, workshop at the Texas Beekeeper Association. Okay, perfect. I think I'm gonna take a quick break here before I get into the 1600s and onwards. And so let's come back at 10, which I think is a good place to stop.